I begin with a helium balloon. I watched this remarkable video of ordinary people sending weather balloons to near space with GoPro cameras and GPS trackers stuffed inside thick styrofoam boxes, and retrieving them hundreds of miles away from where they were launched. And I thought, God, that looks simple, outrageous, and like totally illegal. How can such an act be even technologically feasible, let alone legal? I wanted to find out. So we fill a balloon with helium, get the permissions from the Civil Aviation Authority in the United Kingdom, and identify a day when flight predictors say that it will not drift into an airplane or land in the Irish Sea. The balloon rises. We wanted to see firsthand how balloons and other technologies like drones are opening up the atmosphere for experimentation, exploration, and watching from above. This floating vantage point allows for the optical analysis of spaces, landscapes, species, including humans, infrastructures, deforestation, volcanic eruptions, and things like the internet, whose size are difficult to see from the ground. We track and follow the balloon from the ground, zigzagging across the Pennine hills and pastures, the GPS glitching out because of the sub-freezing temperatures in near space. We didn't know where it would land. It could fall onto the highway, get tangled in an oak tree, land in a flock of sheep, who knows? We were lucky. It crashed in the backyard of a family with one of the two cameras having failed to capture any footage from near space. The freezing temperatures cracked the GoPro camera, destroying its digital data. This broken camera, we thought, was an aberration, but we soon discovered that this glitch, this bug, was a feature. Crashes of technologies and ecosystems is a feature of the present world. Balloons and drones with digital cameras explore the peripheries of what is known and knowable. But inevitably, they come down, sometimes spectacularly in a crash, but usually with some failure. What does the vertical view the balloon's ascent provide, as well as its crash, teach us about the more profound decay of life on planet Earth? We are on the southwestern tip of Iceland. Instead of a balloon, we are flying a small unmanned or unwomaned aerial vehicle, otherwise known as a drone, to map a fiber optical cable that runs from a small station under the ocean and into the global internet. Our question was simple: can the view from above help us see better and therefore care more about the politics of massive things like the internet? To our surprise, a drone crash provided some answers. During our flight, the drone sped away at an alarming speed and seemed to ignore my command to return. It just kept going. This was a liberating experience, frankly, but also terrifying. The euphoria was cut short by the worry that we would lose the drone in the North Atlantic. The drone's experiment in freedom had drained its battery, and it started a descent. The 4 propellers spent their last spins to drop the drone in one of the dune grass patches growing out of the hay bales that covered the internet cable. Like the weather balloon and its broken camera in the United Kingdom, this crashing drone in Iceland told us something about our aspirations to see and know from above.
The number you have reached is not in service.
Here, a crash resulted in a broken drone, gravity grounding it to the earth, entropy taking its toll as the complexity of the drone was simplified into broken parts. But the crash also created an opening for critical thought. What is knowable from above? And from up here, who controls the power to see? The internet cables we were tracing with our drone ended in London at the telehouse. We woke up before dawn and caught the first train to Canary Wharf so we could video the telehouse, where many of the world's internet cables come together. We were interested in using a drone to get a vantage point that no rooftop could offer. Lifting off from a busy roundabout, we quickly vaulted to the height of a 20-story building and began capturing slow, sweeping images from a bird's eye view. But then a security guard emerged from the building and ran towards us. "You can't fly that here," he yelled. We were keeping the drone within our line of sight as per Civil Aviation Authority regulations, and I responded, "Sorry, but we can. We checked the regulations, and we are 50 meters from the building, and this isn't a congested area." I showed him a map. The security guard looked up at the drone hovering near the building and said, "Yeah, but we own it." "You own what?" I replied. "The air, mate. We own the air." The security guard was rightfully concerned that our drone might crash and harm a person or private property. The possibility of bodily harm inflicted by a crashing drone causes reaction, regulation, and moral hysteria. It was becoming clear that urban airspace was being reshaped by the threat of crashing drones, a process which may slice the air into private strips. I wanted to see if the security guard was right. Who does own the air? Who has the power to see and sense life from above? Major technology companies invest heavily in air and space industries. Google has its internet balloon, Loon. Facebook had its internet drone before it turned out to be a dud. SpaceX has its internet satellites and exploding rockets. Virgin Galactic has its troubles with its internet satellites and crashing spacecrafts.
Virgin Galactic was hoping to turn tourists into astronauts within months, but today the project was dealt a serious setback when its Spaceship Two exploded during a test flight over California's Mojave Desert.
And of course, Amazon has its delivery drones.
Amazon is developing a service to use drones to safely deliver packages to customers in 30 minutes or less. Our systems are designed to find their destinations safely.
Are we witnessing the privatization of the atmosphere by big tech? What is being missed in the rush towards capitalizing the air? Atmospheric platforms like drones, balloons, and microsatellites have a future in delivering internet, people, or goods, but can drones be more intimate with the lives of humans and other animals? One controversial place where I could begin this examination was Google's Project Loon, if I could find it. Used to bring internet connectivity in 2017 to flood-ravaged Peru and hurricane-decimated Puerto Rico, Loon was flying balloons over Indonesia to provide internet to those who do not have it or cannot afford it. For Google, this was a form of social or drone justice. For Indonesians, several problems emerge. First, Loon is a closed platform and therefore not transparent nor open for adaptive reuse by Indonesians. Second, Loon's balloons are not controlled by Indonesians, but rather by workers in Google's global headquarters in Mountain View, California. A director of Telkom, a major telecommunications company in Indonesia, claims that Google will bypass us, taking business away and profits to a company located in the United States. Finally, Google has developed in Indonesia without local consultation. Instead, Google established conducive relationships with government officials and telecommunications companies. Thus, the proprietary and offshore nature of Loon can be interpreted as an enclosure of the Indonesian atmosphere for American technology companies that excludes locals, small businesses, and civil society. In response to Google, an Indonesian space technology startup company called Helium developed a balloon that can provide internet access and remote sensing. Helium's balloons are tethered to the ground and thus link information infrastructure to emplacement, domestic use, and local investment. Google's Loon, on the other hand, is linked to international deployment, overseas investment, and data displacement. Together, Google's Loon and Indonesia's Helium increasingly saturate Indonesia's airspace with systems designed to link or network people and objects for a fee. But while internet connectivity is important, what response might these new atmospheric platforms have to the collapse or crash of biodiversity? After months of fieldwork with Helium in Indonesia and numerous discussions about the ultimate application of this technology, my contacts answered with images and sounds in this most recent advertisement. Here you can see the Helium balloon as a tool for Internet of Things connectivity in a massive strip mine. It looks like the Gasberg mine in the Indonesian state of West Papua, the largest gold mine in the world. The ultimate application, it seems, is not drone or balloon justice, but resource extraction. Here the balloons facilitate the crash of ecosystems. This drone monitors a crash of a Google Loon balloon as if it was a UFO. It seems to ask with its cinematography, what is the purpose of this strange celestial object? Is it for surveillance, war-making, internet connectivity, monitoring nature, or control of the Earth from the air? Floating, flying, sensing, and connecting technologies, such as high-tech balloons, satellites, and drones, are called atmospheric platforms. Aerospace engineer Graham Dorrington, who coined the term, discusses the intimate relationships between atmospheric platforms, like his bioprospecting balloon, medicinal plants, and humans in Werner Herzog's documentary, The White Diamond.
The potential is there to go canopy prospecting. Many biologists believe that the canopy is one of the most rich biodiverse areas of this planet, and yet it remains unexplored.
A crash of his balloon brought Dorrington back down to Earth.
I smelled smoke and saw that one of the engines had burned out. And shortly after that, pieces of metal and plastic flew around my ears as the propeller next to me had slammed into its protective rim. We decided to drop a line and make a quick, rather graceless landing.
Clearly, the crashing of the atmospheric platform inhibits Dorrington's ability to find medicinal plants in the rainforest canopy of Guyana. Herzog turns to the Hindenburg crash to make a bleak point about the dangerous desire to use balloons to connect human beings. This chaotic mix of hope, the air, atmospheric platforms, and the hard realities of gravity and the Earth deserves a theory, a crash theory. Anyone who has spent a lot of time flying atmospheric platforms knows crashes. The hardware and software are not perfect. Flying is new for many people. The exhilaration is intoxicating and therefore distracting. The imperfect marriage of drones, people, and environments is an aspect I feel is misunderstood by those claiming that the drone is ushering in atmospheric enclosure, or that the drone is a tool for a totalizing surveillance of nature. The fact of the matter is that these things break, and quite enthusiastically, because of human error, environmental contingencies, and unforeseeable realities. A theory of the crash can be useful for helping us understand experimental technologies of control and how we are actually always out of control. The absence of control is evident in technological advances of drones that outpace regulations, the dream that nature could be controlled through technologies such as drones, and that this technology will be perfectly safe. Drones crash. They represent a disruptive economy designed around booms and busts, and they offer a limited intervention into the collapse of species and humanitarian crises around the world. The drone crash is not merely a metaphor for the sixth extinction. It is not only a symbolic representation of the Anthropocene, but rather the drone crash and the decline of biodiversity is of the same substance. That which links the two materially is entropy, the return to disorder. Like a diverse ecosystem, the functioning drone embodies complexity. The failing drone and the dying world are returning to randomness. From whole, they become parts. From parts, fragments, and a homecoming to geology approaches. Linked to crash theory is broken world thinking, which asks what happens when we take erosion, breakdown, and decay rather than novelty, growth, and progress as our starting points. If things, systems, and ecologies are crashing all around us, then what we need is care and repair of our fragile world. Is the drone, notwithstanding its possibility of falling from the sky, capable of witnessing, caring for, and repairing a world falling apart? What is the relationship between crash theory and drone justice, the use of drones for fostering life?
All flights in and out of Gatwick, Britain's second busiest airport, have been suspended after 2 drones were seen flying near the runway.
Despite the real possibility of a drone taking out an airplane at your nearest airport, you are more likely to have your life extended by drones than to be harmed by them. Drones are involved in life, saving humans through relief work in Nepal, delivering medicine in Rwanda.
Zipline designs, manufactures, and operates robotic aircraft that deliver medicine to people in hard-to-reach places and save lives as a result.
Delivering kidneys in Maryland.
Okay, yeah.
And identifying great white sharks in your swimmers in Australia. Drones also intervene in nature, counting lemurs in Madagascar, spotting once thought extinct plants in Hawaii, combating overfishing in Indonesia, and monitoring the construction of the Dakota Access Oil Pipeline.
I don't call it a drone no more. I call it high hawk. I gave it a spiritual bird name, and we don't call it the pipeline. We call it the black snake. And as I go up, we don't call it flying over there or a mission. We call it the journey, vision, or a dream. So when I talk about drones, I talk about it in a spiritual sense.
Native Americans used drones to help plan and execute non-violent direct actions to stop the pipeline, protect the Missouri River, and slow climate change. While the security guards, defending the pipeline, used rifles to shoot drones out of the sky. Here, drone justice and defending life on Earth are interlaced. And the threat of a crash is ever present. In indigenous hands in Indonesia, drones are primarily used to monitor and map terrain. In the process, alternative maps are created, designating boundaries of traditional lands. These grassroots projects in geography challenge the spatialization of inequality. In this example, Arendra Rajawali and other activists in Kalimantan use a drone to make a detailed map of their forest gardens so that palm oil companies cannot lay claim to these customary lands.
Jadi rupanya masyarakat di desa Situlang mereka belum mengetahui status lahan mereka yang diambil oleh perusahaan sawit ini. Jadi masyarakat pikir mereka sudah menang, mereka sudah berhasil mengusir sawit keluar, tetapi sebetulnya persoalan utamanya belum selesai. Mungkin perusahaan tersebut masih memegang konsesi dan menunggu saat yang tepat untuk kemudian masuk kembali.
We continued the tradition of drone countermapping in West Papua. Using drones, we exposed how palm oil plantations erode river shorelines, weakening the soil with their monocrops. We intended to map regional peatlands, Indonesia has 36% of the world's tropical peatland, which, in addition to being home to orangutans and Sumatran tigers, are important carbon sinks, storing 20% more carbon than non-peatlands. The maps of peatlands are notoriously poor. Companies exploit this ambiguity to convert peatland into palm oil. But our attempts at drone countermapping were failures. In the first attempt, the drone operators did not properly attach the prop. The drone crashed into a nearby acacia tree. In the second attempt, the winds were too severe at high elevation. We had to conduct a tense emergency landing. Our drone crashes and the crash of this ecosystem seemed intertwined at this point.
Now to that volcano eruption sparking a mass evacuation in Bali. 100,000 people there have been told to leave as the Indonesian disaster agency raises alerts to the highest level.
The drive to know from above continued in Indonesia when Mount Agung erupted on the island of Bali in 2018. The volcano was devastating for the people who had to leave their homes and move into shelters. We used drones to monitor the eruption. The use of drones in this context raises questions about how naturally occurring phenomena are constructed by computers, sensors, and software. We flew remote sensing systems high in the air in order to better understand dangerous forces deep in the Earth. We were involved in two different drone volcano missions. In the first, we used drones to create an extremely accurate 3D model of the size of the volcano. With this information, we could see if the volcano was actually growing in size, key evidence that it is about to blow. The second mission involved flying a sulfur dioxide smelling sensor through the volcano's plume. An increase in this gas can tell us if an eruption looms. We discovered that there was a high degree of sulfur dioxide, and that informed the government to raise the threat warning to the highest level. Here, I became interested in better understanding the implications of having sensor systems such as drones flying in the air, peering into the sea, or on volcanic craters, basically everywhere. These tools may help us to evacuate people before a crisis, but it also entails transforming organic signals into computer code. We've long interpreted nature through technologies that augment our senses, particularly sight. Microscopes, telescopes, and binoculars have been great assets for chemistry, astronomy, and biology. But this level of the sensorification of the elements is something different. This has been called the computerization of Earth. We've heard a lot about the Internet of Things, but this is the Internet of Nature. This is the surveillance state turned onto biology. The proliferation of drones is the latest step in wiring everything on the planet. In this case, the air itself is a platform from which to better understand the guts of a volcano. But the drones, sensors, and software we use provide only a partial perspective. There is something not fully comprehended, or more ominously not comprehensible, about how flying robots equipped with remote sensors filter the world through big data crunching algorithms.
16,
As the world is remade in the image of the database, what will be the implications for planetary sustainability and human autonomy? In this future world, there may be less of a difference between engineering towards nature and the engineering of nature. However philosophically rich these musings may be, computerizing the Earth is difficult. Flying a drone 3,000 meters to the summit of an erupting volcano is not easy. Piloting through a sulfur dioxide plume is hazardous to a cyborg's existence. Several different groups worked on Mount Agun to complete the task of 3D modeling and collecting gas samples from the volcano, and a few expensive drones were lost. For some, the ascent was too steep. For others, the crater gusts too intense. Or perhaps the air was too thin to create thrust. The drones were cleansed by Balinese priests, but might have been too impure to fly over the crater. They became sacrifices to what the Balinese Hindus consider a sacred mountain. Again, these crashes show that the informationalization of nature is far from complete. A different force is at work. Bali is on the southern edge of the Coral Triangle, the global center of marine biodiversity that includes the Philippines, most of Indonesia, and Papua New Guinea. We traveled to Bunaken Marine National Park in northern Sulawesi, Indonesia, in the heart of the Coral Triangle, to see how drones might be useful in identifying coral bleaching. A response to a warming ocean, coral expel their nutrient-providing algae, leaving white, dying, starving coral, easy but heartbreaking to identify from the air. Across several days, we collected over 500 high-definition still images of the reef and stitched these shots into a single, massive, highly accurate map of bleached coral. The drone crash that happened here was unspectacular. After avoiding the spears thrown by young octopus hunters, the little drone we used here met an unceremonial end, tipping from a pier in high wind into the ocean. Attempts were made to rinse the salt from its components in the freshest water we could find, but the salt calcified in the motherboard, frying it. The company shipped out another drone, insurance paid, as if the first were merely disposable. And I guess it is disposable, neither recyclable nor reusable. The churn of this disruptive economy has regular planned obsolescence. Our drones' copper, silver, gold, palladium, and indium were slated for a shallow landfill on this paradise island. Still in search of the fabled Loon, we traveled to Sri Lanka, where Google was using balloons to create internet access in the Central Highlands. Again, finding nobody who knew anything about the trials of the balloon except for evidence for Loon balloons crashing, I had to develop a different approach. It was here that I discovered that the Sri Lanka Wildlife Conservation Society uses drones to frighten marauding and hungry elephants away from farmers' fields, hoping to stop these dangerous encounters between humans and elephants. We tested this concept on elephants feeding in a trash dump, a rather depressing field site as fat elephants chased garbage trucks to be the first to pick through the human waste. We were able to intimidate them with our buzzing, irritating, insect-like drone, and that was the point. The next step was to arm the farmers with drones so that they can use them to scare away elephants before they ruin their crops or destroy their homes. Elephant existence has been mediated by human technology for thousands of years in Sri Lanka. They adapted to the damming of rivers, the draining of swamps, and the creation of reservoirs. Then the conservation parks came with their roads, patrols, and tourists. Then, as human populations exploded, immeasurable miles of electric fences were erected to dissuade the elephants from leaving these parks. Drones are the latest technology to mitigate the entanglement of people and elephants in Sri Lanka. One night, we went out on an elephant survey equipped with a drone with flashlights. Chandima, a conservationist at the Sri Lankan Wildlife Conservation Society, expressed the difficulty of furnishing drones to untrained farmers. How will they learn to fly the drone, charge it without dependable electricity, and repair it without expertise? The eventual crash of the drone and its incapacitation looms over the ideal that farmers could use drones to resolve the ancient conflicts between humans and elephants in Sri Lanka.
So, yeah, much more professional.
Yeah.
I mean, you need an actual kind of a battalion.
Yeah. Yeah, so like with the elephants, you need to have experience with the elephants. You shouldn't be scared of elephants, right? All these factors, little factors, like, you need to consider. So when you do this kind of, thing. So of course you need to have a a technician who can, fix these things. If you say, like when we fly the drone in a real situation, so you need to have a handy guy. Okay, guys, I can fix this, and those kind of things. So people don't consider those things, but those are the things that matter really in the field.
Absolutely.
Like, places like this, yeah. So still, it's in the development stage. There's a potential, but still we don't know exact potential of these things in the real fields.
My family was considering selling our old property outside of Seattle, Washington, so I volunteered to survey the land with my drone. We returned to the States, where I became aware of the Washington state proposal to ban drone flying over endangered orcas in the southern Puget Sound. This fascinating footage was collected by Douglas Shee, a wealthy real estate agent from Mercer Island, Washington. Along with 15 other crafts, Shee was with his family on their 45-foot yacht following an endangered southern resident Puget Sound orca pod when he decided to use a drone to get a vertical view of the breaching family. This is a rare sight because sound pollution, toxic chemical pollution, the demise of the salmon populations have made existence tenuous for the pod that frequents the waters around Seattle. This pod made international news when one mother, Taliqua, carried her dead calf for 1,000 miles in 17 days following what one observer called a funeral ritual or ceremony. The National Oceanic and Atmospheric Administration, NOAA, used drones to track Taliqua and her pod and used photogrammetry to measure the width of the orcas and predict whether or not they were pregnant. 3 mothers have been identified in this manner in the summer of 2018, and 1 baby has been born in the winter of 2019. But the population is dwindling, down to a 30-year low of 75 individuals. And researchers are considering other reasons for their demise. Oil tanker traffic is set to increase 7-fold in the Puget Sound. Warming water, viruses from dogs and humans crossing the species barrier are other explanations. Again, drones are used here in conservation work. They fly through the misty exhale of whales to collect microbiota, lung content, to judge their health or sickness. but it is most likely that they are starving because of the absence of Chinook salmon, which have been overfished and decimated by pollution. But while conservation drones are used to monitor pregnancies and respiratory health, they are also deemed a problem for the orcas. This brings us back to the drone photographer Douglas Shee. While this is beautiful footage, it was also collected in a manner that violated Washington state law that requires all operators of crafts and other objects to stay 200 meters away from the orcas. Shee's DJI drone was 20 to 30 meters above the whales when spotted by Fish and Wildlife Sergeant Russ Mullins, and for this violation, he received a ticket for $1,025. Shee didn't like this, and he fought it, and it cost him 10 times the fine's amount in lawyer's fees. And Shee won, because the law did not specifically mention drones, but rather objects. Washington state congresspeople responded to this ambiguity, introducing a bill that would specifically prohibit drones from being closer than 200 meters from orcas. State senators were confident that the orca drone bill would become law. But at the last moment, State Senator Jim Honeyford, a Republican from the eastern Washington county of Sunnyside, submitted an amendment that removed all prohibitions against using drones around orcas. In an interview with me, he said he was opposed to any regulation that might limit the economic potentials of the developing drone industry. For NOAA, drones are important tools for observing pregnancies and orca births. They are tools with which humans may slow extinction. Drones are also objects that harass and distract, causing what Mullins tells me is an arms race of video technologies competing for the best videos of orcas for social media. A crash of drones, boats, or species is what is to be avoided through these laws. But regulations are also designed to not inhibit disruptive technological innovation. Sergeant Mullins is mainly concerned with crashes. Piloting a boat is difficult enough without the added challenge of flying an object in the atmosphere. Here is Sergeant Mullins discussing the monitoring of the orcas.
We'll follow the whales around for 10 hours a day.
Oh my God. What distance?
Well, we usually stand off a little more than the minimum and just observe.
Good. I can imagine.
But everyone's required to stay 200 yards, away from the whales. So it doesn't always happen.
10 hours a day for in certain
sometimes
periods.
5 days a week.
Okay.
Yeah.
They're on their own on the weekends.
Well, no, we're usually there on the weekends. It's Monday, Tuesday, Wednesday that we usually take off.
Okay.
They're the less busy days.
Oh, they are? Okay.
Yeah.
Wow. So we're in a situation where we're almost perpetually monitoring this pod. Is it the pod of 130 odd?
3 pods.
Yeah.
I think the last count was 76 total.
This level of monitoring, both inside the bodies and breath of the whales and outside 5 days a week, reminds me of the insights from the Agung volcano in Bali. There, as here, I witnessed the early attempts at quantifying nature through software systems elevated in the air. And as we saw in Bali, this effort was incomplete, the drones imperfect. Either not properly ritually cleansed or ill-equipped for high flying and tough winds, the drone plummeted near the crater. Nevertheless, the aspiration to not only monitor but to intervene in nature remains. When I returned to the United Kingdom, I witnessed the latest trend in this flightway, the addition of artificial intelligence to drones in the computerization of nature. One cold February morning, we meet at the Knowsley Safari Park outside of Liverpool and drive out to a parkland populated with African species such as Sitatunga, bongos, and several white rhinos. I am here with a team of astroecologists, experts on applying space science to Earth conservation. Professor Serge Witch, who is known for his work using drones to count orangutan nests in Indonesia, is flying a drone over the rhinos. Because it was cold, the battery only gave us 20 minutes to get to and follow the rhinos as they meandered across a road, frightening axis deer from their sanctuary under a pagoda. This data will be fed into an artificial intelligence system in order to teach it to recognize the heat signatures of rhinos. as distinct from other animals, including humans. The hope is that this complex toolkit could be used by rangers in national parks in South Africa to help identify and stop poachers. With the battery draining, the wind picking up, and valuable footage collected, Professor Witch flew the drone back to us. As the drone got closer to the electric fence that separated us from the rhino, it refused to get any closer and drifted uncontrollably back towards the animals at an alarming descent. It crashed, thankfully away from the rhinos and other species before flipping over, breaking a few propellers, but saving the expensive infrared camera. The ecologist quickly gathered in one of the 4x4s and retrieved what was left, a rhino having first licked the lens. We don't know why it crashed, but the footage survived for humans to code for artificial intelligence. The question is, will any of these species survive during this period of human-caused extinction? Atmospheric platforms witness the Anthropocene, an age of irreversible human impact. They are also tools with which the atmosphere is privatized, as well as reclaimed as a commons. As such, the drone floats between entropy and its negation, which is life. The drone is imperfectly intertwined with photons, electrons, humans, and non-human others. Every drone crash results in a mess of propellers, plastics, plants, soil, and sand. Drone justice, the extension of life from above, emerges broken yet repaired from this twisted mesh. Drone justice is the flip side of crash theory. While drone justice is about prolonging and diversifying life, crash theory is honest about destruction and committed to restoration. Here, the drone hovers between death and its care. Withering coral reefs, palm oil plantations, astroecologists, carbon dioxide belching volcanoes, trash-eating elephants, carbonized atmospheres, crashing drones, rhinos, and sea turtles in hot and acidified oceans. As witnessed by the drone sensors, this is the multi-species entanglement of drone justice.
Not be the same. Few people laughed. Few people cried. Most people were silent.